Yeah, I said, have you heard about the topic before? Permutations and combinations. Can you hear me? And I think it's your speech because me, I can hear you loud and clear. Let me share my screen. You cry. Okay, so today, let me introduce you to this book, Permutation Combination by Ichiyama. Uh, it's a very good book. So far, that's the book that I. Hello, my voice is down. Oh, see, can you hear now? Can you hear me now? Can you hear now? Okay, you disconnect and join again. No concept. Okay, is it better now? And turn off your camera screen. You save data. Okay, so I hope you can see my screen. Okay, so let's start. The whole idea of permutation and combination boils down to the factorial concept, right? So now this is the introduction. The factorial of n different objects, denoted by n factorial, is like the exclamation mark, or sometimes by n permutation p. Highlight. N permutation p, right, is the same as n factorial. It's defined as is the number of arrangements of objects, or the number of arrangements of the n objects taken all at a time in a straight line, right? In arranging n different objects taken all at a time in a straight line, the first object can be chosen in n different ways. The following this, the second object can be chosen n minus 1 different ways. The third object n minus 2 different ways until n minus 1 object is chosen. So the nth minus 1 is one way. Hence, by definition, blah 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 blah. A whole lot of stuff. So I want to move this thing forward. So the idea of factorial boils down to the fact that if there are maybe n objects, let's say for example 5 objects, right, and we want to see the number of arrangements taking 5 objects all at a time in a straight line, right? You can arrange the first element if there are 5 elements. You can arrange the first one 5 different ways, right? You can arrange the next one 4 different ways, 3 different ways, 2 different ways, until they get the last way. You understand? That's the definition of the factorial. So n factorial is n minus 1, n minus 2, n minus 3, n minus 4. until you get to 1. Until you get to 1, because 1 is the last stop. So if you get 5 factorial, basically it means 5 times 4 times 3 times 2 times 1. 6 factorial, multiply 6 downwards up to get to 1, right? Very good. So if I give you 3 factorial, uh, it means 3 times 2 times 1. If I give you 7 factorial, it means 7 times 6 times 5 times 4 times 3 times 2 times. You just multiply down until you reach 1. So if I give you n factorial, it means n minus 1. You see that 7 minus 1 gives you 6. N minus 2, n minus 3. Keep on until you get to what? I'm going to look at this thing. Until you get to what? Until you get to 1. Right? Keep on multiplying until you get to 1. Right? So that's the whole idea. Now, another concept you have to know is that 0 factorial is also 1. And 1 factorial 2 is what? 1. Now, why is 0 factorial equal to 1? Now, let's see something. We know that n factorial is the same as what? N times n minus 1 factorial. Now, this concept comes from the fact that if you have something like 7 factorial, I can write it as what? 7 times what? 6 factorial. Because 6 factorial is the same as what? 6, 5, 4, 3, 2, 1, multiplying 1 downwards. Do you understand? So similarly, if I have 0 factorial, 0 factorial, right? The same as, no, let me use 1 factorial rather. So I have 1 factorial, 1 factorial. The same as 1 times what? 1 minus 1 factorial. And 1 minus 1 gives you 0 factorial, right? So now we have this one. 1 factorial equals 1 times 0 factorial. If I want to make 0 factorial the subject, making it stand alone, right? If I want to make the 0 factorial stand alone, it means 1 factorial over 1 equals 0 factorial. We know that 1 factorial is 1, so 1 over 1 is 1. Then eventually 0 factorial is the same as what? 1. Okay. So now if I give you 10 factorial, 10 factorial, what will be the answer? 9 factorial, very good. Or you can keep on continuing. 10 times 9 times 8 times 7. Even you can end at 7 factorial. Depending on the factor, sometimes you'll be using it to divide some elements. Right? Very good. So now let's continue with some examples. Now these are some properties of factorials. N factorial is what? N minus 1 factorial. 0 factorial is 1. 1 factorial is 1. According to property, higher factorials can be written as a product of terms, including to include a reduced factorial term. Right? So if you have a higher factorial, something like 10 factorial, you can write it in a lower term so that it can reduce some other factorials. Right? Something like 2n factorial. It's a note that in property 1, the first one over here, we can replace n by say 2n so that the property will now take the form. So if you have 2n factorial, it becomes 2n, 2n minus 1, 2n minus 2, 2n minus 3. Do you get it? So this one can even end at 2. It can continue on the same thing, 2n minus 4. Now, are we okay? Okay, so these are some examples of the property where n is known as a positive integer. If you have 4 factorial, you can do it 4 times 4 minus 1 factorial, right? Or you can end at 4 times 3 factorial. Since 3 factorial is the same as 3 times 2 times 1, means 4 factorial is the same as 4 times 3 factorial. Similarly, you can do it for the other elements. 5 factorial, yeah, they are there. And also learn how to punch the factorial on your calculator. So for example, if I want 10 factorial, I press 10, then I press the shift and the button be below the mode. Right, the button below the mode. You get it? Okay, I have to do my mouse this thing. Mouse point. Okay, so let's continue. So now if the value of n is not yet known, then form n factorial equals n minus 1 in similar cases. So you don't know if you don't know the value of n, right? Can keep on forming it until it ends. And if n is the same as n minus 1, it becomes n minus 1, n minus 1 factorial. So for 2 terms. So the whole idea of that is that when you are the more you are going down, just subtract minus 1. So that's what they are saying over here. Right? Just subtract, keep on subtracting minus 1. So if you have n 2n minus 1 factorial, it becomes 2n minus 1 as the first element. Then in the next one, it becomes 2n minus 1 minus 1. Then keep on going. I hope you're okay. Okay. Now, note that we can go as far as to any number of the terms if it fits dim, not just 2 or 3 terms. Now, let's go to factorial divisions. When one factorial divides another factorial, we look out for the higher of the two expressions. Next, we can reduce the higher factorial expression until it levels with the lower factorial expression to cancel or to facilitate cancelling. So, for example, if we have 6 factorial, if you have 6 factorial over 5 factorial, right? Listening. So if you have 6 factorial, 5 factorial, you can. Which one is bigger? Very good. So with the 6 factorial, you can break the 6 factorial down, right? So that it becomes 6 times 5 factorial. Then it will cancel the 5 factorial below. Then the answer becomes 6. Are you okay? Nice. So that's the whole idea of factorials. Now let's look at something. N factorial over n minus 1 factorial. N factorial over n minus 1 factorial. What happened? I can break the n factorial down as n times n minus 1 factorial all over what? N minus 1 factorial. Because this one is bigger than this. The one at the top is bigger than the one below, right? So this and this cancels, and the answer becomes n. Okay, let's see. Evaluate the following: 10 factorial over 7 factorial. So try 10 factorial over 7 factorial. It becomes 10 times what? 8 times, no, sorry, 10 times 9. So 10, 9, 8, 7. Then I'll end at 7 factorial. all over 7 factorial. So that the factorial will cancel factorial. Now we left with what? 90 times 8. 720. Are you okay? Another example, 8 factorial over 5 factorial, 3 factorial. 8 factorial over 5 factorial, 3 factorial. How do I simplify this? This becomes 8 times 7 times 6 times 5 times, okay, I can end at 5 factorial. All over what? 5 factorial times 3 factorial. Are we okay? Then after that, this cancels this. It becomes 8 times 7 times 6 over factorial. But I can simplify 3 factorial simply as what? 3 times 2 times 1. So 8 times 7 times 6 over 3 times 2 times 1. Then 2 goes here 1, 2 goes here 4. 3 goes here 1, 3 goes here 2. Then it becomes 4 times 7 times 2. 6, 4 to 8, 8, 7, 56. I hope you understand. Very good. Now, let's simplify this one. Let's do this 3. Or you go do screenshots. Okay, okay. I hope you are getting the idea of the factorials. Anyway, the video, scroll back to navigate. So let this thing there. Mhm. So let's take this example. To simplify n factorial over n minus 2 factorial. Now, how do we do this? We know that which one is a factor of the other, or which one is bigger? Very good, because minus 2 is less than the one at the top. So I can break the n factorial down until I reach n minus 2, right? Because it will cancel the n minus 2 below. And then this cancels this. We get n minus 1. It becomes n square minus n. Are you okay? Okay, so let's do the second one. You will do the second one. N plus 1 factorial over n. Always ask yourself which one is bigger. Then break the bigger one downwards. Okay. So what do I write? No, I don't repeat the factorial because I'm going downwards. So I don't have to. Okay, talk, and let me write. Okay, this one is not correct. The whole idea of factorial is subtraction. Mm. You are subtracting one from the whole idea. That's why 10 becomes 10. 10 factorial becomes 10 times 9 times 8 times 7. So, you understand? Don't confuse yourself. We are all about subtraction of 1. So ask yourself, over here, which one is bigger? The one at the top or the one below? So big, small. So it means you have to break down the big. So if you're breaking it down, how will you break this one down? If you are breaking 10 factorial down, how will you break it down? Times 9 times 8. Continue. You understand? Now, what is the 9? The 9 is the same as what? 10 minus 1. And the 10 will come by itself, right? And the 8 is 10 minus 2. And it continues. So if the 10 is no more 10 and it's n factorial, or let me say n plus 1 factorial, in this case, what happens? The other hand, at the end of the hand, it will repeat itself again. To come the first element times the same thing minus 1 times the same thing minus 2 times the same thing minus 3. So, so how will you write this one? Plus n plus 1. Very good. All over what? No, you don't have to open another bracket again. You know why? You end at this point because when you simplify this one, it becomes n plus 1. Then 1 minus 1 becomes 0. So it becomes n factorial all over n factorial. And the n factorial cancels n factorial. Our final answer becomes n plus 1. Okay, very good. Let's try another one. No, you let me write n plus 1 factorial by n minus 1. Let's try this one. N plus 1 factorial. So n plus 1 factorial over what? Minus 1 factorial. Very good. Now, which one is big? Which one is small? Big. So what are you going to do? Mhm. Very good. Minus 2. We need to bring the factorial. Okay. What will cancel what? So you have to simplify. Okay. So it becomes n plus 1 n factorial. The n 1 minus 2 is negative. Good. So the answer becomes, but still, we have n factorial. You don't have to let a factorial be in the listing expression. You understand? You shouldn't let a factorial be in the expression. Because the factorial, we don't know the value of n, so it will never end unless it cancels something. You can see that over here we still have n factorial here. So what we have to do is that we should continue. Over here. N minus 1, another n minus 1, or let me say n minus 2 plus 2 factorial. That means this one too can be continued. The n minus 1 can continue this one, n minus 2 factorial. Or wait. Anyway, we are before we need to. Let me delete this one and see. I'm cleaning the thing, it's not cleaning. Let's take it again. BBI baby is minus 1. So let's expand the one at the top until we come and get something below. So n plus 1, right? Then you come again, n plus 1 minus 1. We don't put a factorial here because we want to continue. Then n plus 1 minus 2. Then we come down, n minus 1 factorial. But this the n minus 1 can cancel this one. That's why we will end. If you put a factorial there, this you are ending there because you have a factor. Now this becomes n plus 1, n itself, right? Then n minus what? 1 factorial all over n minus 1 factorial. Are you okay? So this becomes this. Then we get n square plus n as the final answer. Please, do you understand? Let me go over again. The reason why I don't bring factorial here is because I keep on doing. For example, if you have 10 plus 1 factorial, right? It's going to be what? 10 plus 1 itself. 10 plus 1 minus 1. So if I see that it's going to cancel something below, then I stop at that point and I put the factorial there. Are we okay? Very good. So that's why I have to remove this thing from there. Okay, let's do another one. 3n minus 1 factorial over 3n minus 3 factorial. 3n minus 1 factorial over 3n minus 3 factorial. Which one is big? Which one is big? So big and small. So now it means that I can break the one at the top until I see something below. So it becomes 3n minus 1, 3n minus 2, and 3n minus 3 factorial all over 3n minus 3 factorial. This and this cancels the next ones, they multiply binomial expansion. So 9n square minus 6n minus 3n plus 2. 9n square minus 9n plus 2. Are you okay? They even ended at 3n minus 1. Right? Let me give you another example. Number 5. n factorial n factorial over n minus 3 factorial 3 factorial. So n factorial over n minus 3 factorial 3 factorial. Now, which one is big? The top or the down? The top. Because and which one is a factor? This one is a factor of this. Sorry, the one below is a factor of the one at the top. And the 3 factorial, that one we can expand it, is a number. So let's continue. This becomes what? Now expand it, let me see. And it's very good. And we know that 3 factorial is what? 6. And that's 3 times 2 times 1. Now this cancels this. And now simplify the ones at the top. It's going to give you a cubic function. So you can even leave it that way. N minus 1, n minus 2 over 6. Yes, that's one set of n minus 1, n minus 2. Okay. Now let's go to factorial equations. So if n factorial equals m factorial, then n and n are equal, ignoring the factorial symbols. You get over here, that's what I'm talking about. But if n factorial is equal to m, then the m without the factorial symbol must be first expressed into factorial. Then m without the factorial symbol must first be expressed into a factorial. Now, if we have n factorial equals 6 factorial, factorial and factorial cancel, you get 6. And if n factorial is equal to 6, then change the 6 into something factorial. Do you understand? So 6 is the same as 3 factorial. So what about if you have 18? The 18 will become what? 6 factorial, 3 factorial times 3. Okay, I don't want to give questions from my head. Let's look at some examples. Number 1, n factorial equals 24. Okay. Do that, I'll send you the PDF, then I'll forget. Okay. N factorial equals 24. So let me move to the top. Hope you are enjoying the class. So factorial equations. These factorials they come in the EMAS objectives, and uh, the compulsory part, the 1 to 5, you get at least one question or two questions over there. And sometimes too, they come inside the probability and statistics. Okay, so let's see n factorial over what? Cos 24. Cos 24. Right? Over here, you can go on your calculator. Punch the numbers factorial. 2 factorial is what? 2. 3 factorial is what? 6. 4 factorial, 24. You see that thing? So it means n factorial can be written as what? 4 factorial. Therefore, n is equals what? 4. Another one, n minus 1 factorial equals 120. N minus 1 factorial equals 120. So what factorial will give you 120? Let's go and check. 5 factorial, 120. So n minus 1 factorial equals 5 factorial. The factorials will cancel each other. Then you get n minus 1 equals 5. N equals 6. Another one. N permutation P. N permutation N equals 720. Now, N permutation N, number 3. N permutation N equals what? 720. Now, how will you do this one? Now, whenever you see N permutation N, from the definition, from the first page, it says that the factorial of n different objects denoted by n factorial or sometimes n permutation n. So anytime you see something permutation, the same thing is the same as n factorial. Not permutation, but a number permutation itself is a number factorial. Permutation is the arrangement of objects, the straight line, where order is taken. BBI permutation, per. But when you come to combination, it's to France. It's like how you are cooking rice. Akɔtɔ a friend saying, ɛmo ne wakye ne salad ɛmo sɛ a combination ntina ɔtɔ aduane ɔsɛ aduane wey dey solid combination because there's no order. There's no order ɛfrafra and when you are eating it you mix them so to France combination but if you want something that is order what you are saying ɛnyɛ sɛ oh order aduane o. For example, what do we do in types of order? We want to arrange some things in order, something like ranking. You want to rank exam position. We want the first 5. So we are going to rank them in order. You don't worry, when you reach permutation, you see. And sometimes maybe if you want some people to sit in a certain arrangement, maybe your core function be as here. The people are sitting on the bench. Footballers are sitting on the bench. The coach should be on the odds. What's on the first formula? Hello. Yes, fine. Please text me on WhatsApp. I'm in live class at the moment. I'll respond to you on WhatsApp. Okay, okay. Thank you very much. Okay, let's continue. Once if I say Dimoti bench, so footballers, right? In our seats. Now per se coach, etna assistant coach, na captain. They there you and the rest to France near there. Something like this we need something like permutation. And maybe you are building a house. If you are building a house, you need what? Foundation. After that, lengthening. You go and build this thing. With lengthen level. Then after that, put the roof on it. It should be a anything that demands order in arrangement. Yes, teaching. Let me make sure that I'm not teaching you the wrong thing. Let me Google it for you. So each of several possible ways in which a set or number of things can be ordered or arranged, and the possible ways by which uh, a number of things can be arranged is the in mathematics is the action of changing the arrangement, especially the linear order of a set of items. So they say what are the permutations of the word of the figures 1, 2, 3, 4? The answer is 24 because there are 12 even permutations. Don't worry, we'll do it. Now, over here, we know that n permutation n equals 720, the same as n factorial equals 720. And what factorial give you 720? Let's check 6 factorial. So this becomes n factorial equals 6 factorial. N equals 6, right? Before that, there's also the definition of permutation. that side fast when do this thing. There's a definition. N permutation R is top factorial, top minus down factorial, right? If you have something permutation something, it's I like to use the top and down. Top permutation down. It becomes top factorial, top minus down factorial. Are we okay? But when you go to combination, top combination down, it becomes top factorial, down factorial, top minus down factorial. Hmm. So when the top and down becomes equal, like in this case, top permutation top, it becomes what? Top factorial over top minus top factorial. Then down part becomes top factorial over 0 factorial. 0 factorial is 1, so it becomes t factorial. So t permutation t factorial. Do you understand? So that's why n permutation n is the same as n factorial because of the definition. To understand. So let's continue. What's as factorial equations? And let's solve this. 5 factorial n factorial equals 6 factorial. 5 factorial n factorial equals 6 factorial. Want to find n? So n factorial become 6 factorial over 5 factorial. Are we okay? Then n factorial will be 6 times 5 factorial over 5 factorial. This cancels this. N factorial equals 6. We know that it's the same as n factorial equals 3 factorial. Then n becomes what? 3. Are we okay? Let's look for another equation. N factorial times n factorial equals 576. N factorial times n factorial equals 576. Can we do factorial square? Let's go and check if it's possible. Yes, it's possible, right? Anything times the same thing, the same as the same thing squared. Okay. Then you square root both sides. So n factorial becomes the root of 576. What is root of 576? 24. So n factorial equals 24. And what is 24 in terms of factorial? Let's take 4 factorial. 24. N factorial is 4 factorial. N is 4. Are you okay? Okay, so I'll give you questions that you do on your own, and let me see if you've understood the concept well. So I think after this one, there are no more examples. Revision questions. Okay, so do this one. N factorial over n minus 1 factorial equals 8. You want to make screenshots? Okay. Ta-da-dum, ta-da, yeah. Shabba-bum-ba-ba-bum. Sho-da-de-de-so-so-de-de-so-so. Mm. Bum-bum-bum. So lots of family fa so so do. Mi re do re mi so do. Fa mi re 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 do fa. Okay. What will be the solution for this? You can solve it on paper, then later you mention it and I write it. But I find repose. Please, no, please 60. Send me the screenshot of the payment and I'll send you the latest report. Don't you what is this report? You have to, depending on the level of you to have. I think you need, as you said, one review. So you just need to look at the semester. Then you send me a screenshot of the payment. Okay. How did you solve it? No. Yeah, me class. Okay. Let me have a flow. You said okay, so how do I expand it? Say it and I'm right. Yeah, when I watch chess okay. Okay. N factorial over n minus 2 factorial. Let's find that one. N factorial, n minus 2 factorial equals 12. Find that one. Do okay, let me try. Which one is big? The one at the top. So keep on expanding the one at the top until you get something like the one below. Then you end there. Then you are good to go. N minus 1 equals 12. How na air confusing now? So n squared minus n equals 12. Then what do you do again? This becomes quadratic. N square minus n minus 12 equals 0. Becomes a quadratic expression. I used to calculate mode 5 try. Mode 5 try. Quadratic. 1 is the coefficient of the first one. Negative 1 is the coefficient of the second one. And negative 2 is the coefficient of the last one. So x is 4, negative 3. So you leave 3 lines, line 1, line 2, line 3. The answer, x is what? 4 and negative 3. So 4, I don't want to use x, I'm using n. So 4 negative 3, right? Then you move them across the equal sign. So this becomes n minus 4, n plus 3 equals 0. Multiply them, n times n minus plus 3 minus 4, n plus 3 equals 0. N squared plus 3n minus 4 minus 12. Right? So these are the values of n. We solve n plus 1 factorial, n minus 1 factorial, 2 factorial. N plus 1 factorial over n minus 1 factorial, 2 factorial equals what? 10. This one too. When they are writing exams, you give them permission to write. Oh yeah. That's so much fun. Dear, dear. Hey, you people, stop work. Ah, okay. So solution. Hey, please connect charger. My pen is on no battery. Cool. Use this. Let's finish. We'll finish now. So let's solve it. Hurry up. So what do I write? Very. Yeah, simplify before you cancel. Let's do 2 multiply the 10 so that you get 20 over here. So this one is cancelled. N square plus n minus 20. So what do I write down? Okay. Atasa. Oh, at this point, just take this one, multiply it, erase everything here. Take this one, multiply it, erase everything here. Mm-hmm. Oh, very good. Okay, very good. Hmm. Now that my yeah. Okay. So now that my laptop is going on, my pen is going on low battery. The rest maybe I'll give it to you as homework. Yeah. You see, say you dey enjoy. When you learn to do, you understand. You really understand. Okay. I'll be foul. I'll be foul. Okay. So these are all review questions. We've not started the permutation itself. It's the factorial concept that we are doing. When you start the permutation, that one it has. You see all the things I've written here on the left side. Those are the different types of permutations that we have. We- So Hello. Uh, how are you? Give me. Oh, many happy. Thank you very much. I'm in an online class, so give me about 30 minutes. I'll call you again. What's some more questions? So this one, solve all the odd questions. Odd means 1, 3, 5, 7. Let me make it small so that I'll send it to you as PD. I should send it to you as a picture file. If let me do full screen that is man. Hmm. So screenshot this one. So, and do the odd ones. Let me and the kakra. Mm. Charlie screenshot it. So only na. Na best me dane screen na unya no full way. Ya ne pa. That's how I want you to do it. If request, I hope it's bigger now. You can screenshot and rotate your screen later. Take it in your gallery. Me screenshot. Let me find two group. Let me boys first. Okay. Yeah. Yes, yes, yes. Okay, okay. I think with every session we have to solve one past question. What do you think? So let's start from today. Past question will be group anymore. Email. Maybe when you can you solve this one? No, no, I'm asking just if you can solve it. So I will skip. It's inverse. Binary operations. Okay, how about this one? Alpha beta. Okay, let's see if you can solve this one. I hope you can see. If a candidate, if alpha and beta are the roots of the equation, such that alpha square plus beta square is 21, and alpha plus beta is negative 3. Find the equation whose roots are this. If alpha and beta are the roots of an equation, so roots, the roots means that they are the solutions. Oh, let's say it's not working. Charlie, the laptop, the lesson is on low battery. The pen is on low battery. In evening, maybe I'll be free. Okay, okay. Okay, you take care.